record the presentations tonight. We are going to record the presentations tonight. So if during the presentations you want to turn your cameras off, please feel free. Nobody but the speaker should be showing up on the recording anyway. And just a couple of housekeeping things before we get started. If you could please stay muted unless you are speaking, that would be great. If you could save your questions until the end of each section of the presentation, that would also be helpful. But if you don't want to forget your question, please feel free to write it in the chat and we'll get to it as soon as we're able. And then I'm going to ask each speaker to introduce themselves as their section comes up rather than introduce everybody at the top. And we'll go from there. So again, thank you so much for being here tonight. We have a lot of information to convey to you. A lot of you joined us earlier for our one of our other public meetings, and you know that we've been working with all of your communities very hard since September. Your communities have really done a lot of work in a short period of time. So now is the great unveiling as we finish up. The project ends at the end of the month, so we're coming up to the end here. So my name is Carrie Snyder. I'm the Advocacy Director for the Neponset River Watershed Association. And I'm just going to orient you to what it is we're going to be talking about today. So first, we're talking about a project that encompasses the entire Neponset River watershed. The Neponset River, as most of you know, starts in Foxborough, right by Gillette Stadium, and it runs about 30 miles up to Boston and Quincy, and it flows into Dorchester Bay. It's the watershed itself in its simplest form is simply a system of water that all sort of comes together. Basically, any rain that falls within the yellow area here eventually drains into the Neponset River. It might first soak into the ground and recharge groundwater and flow through the soil to a stream, might flow directly into a stream, or it might flow through a storm drain on your street and get to a nearby brook or stream or other surface water. But eventually it all gets to the Neponset River. And so because all of this water is connected, we feel it's really important to sort of look at some of these water issues holistically as a region for the entire watershed. So this is our project team. We were able to coordinate 12 cities and towns in the watershed, along with the consultant team of the Neponset River Watershed Association, Weston and Sampson, and the Metropolitan Area Planning Council. The project was funded through the Municipal Vulnerability Preparedness Program, or the MVP program that is funded through the state of Massachusetts. And I want to give a special shout out to the town of Dedham, who served as the fiscal agent, coordinating all of the grant paperwork. So I want to give a big thank you to Dedham. Without them, this project would not have happened. So, as I said, your communities have really done a lot of work in a short period of time. The goal of the MVP program is to support cities and towns in their efforts to improve their ability to withstand and bounce back from the impacts of climate change. We'll get into what some of those impacts are a little later. But this particular project began in September and will finish up at the end of June. And during that short period of time, we've really been able to get a lot of work done. So this is just a very basic overview of the core elements of this project. A big part of it was developing a watershed-wide flood model, which you'll hear all the details about towards the end of tonight's program. And that's going to model sort of where the water is going and where we think it will go with climate-driven precipitation. We also looked at a neighborhood in Dedham that does experience flooding already and is expected to experience more flooding in the future, and sort of used it as a pilot project to model what might be done in some other high-risk areas around the watershed. We also worked with the towns to come up with a framework around which they can work together on regional strategies to reduce some of the impacts of climate change. And the reason we did this is because most towns aren't set up to work across town boundaries on their own. So we'd like to facilitate that work, because really no one town can do everything they need to do alone. We also conducted a technical assistance workshop to talk about some of the strategies that might be used by cities and towns, including land use strategies and what types of regulations we can put in place today to make sure that construction projects and other projects are climate resilient. And finally, we engaged with the community. We went into the schools, we visited all the 4th and 5th grade classes of the participating towns. We held a focus group in the lower Neponset, and we've held a couple of public meetings and tried to really identify who's interested in this work and who wants to support the work. We'll be getting into that a little bit more later in our breakout groups. So I'm now going to turn it over to Jeff Frisch to talk a little bit about why all of this work is necessary. Jeff?
Hi, everybody. Thank you again for coming tonight. I am Jeff Frisch. I'm the Watershed Resilience Planner at the Neponset River Watershed Association, and I will be talking about what's the problem, climate-driven effects in the Neponset River watershed. So first, we'll start off talking about what's climate versus weather. Climate is kind of the longer range, what we're used to seeing. It's the average pattern over decades. It's what we expect to see based on what has happened in the past. It's the long-term weather patterns that we're used to seeing and we're used to experiencing. And it's things like the average high or low temps that we expect to see at any given day, or how much rain is falling in a 1% flood event, which is a flood event that happens should happen once every 100 years. We'll get into that a little bit more later. But weather is something that can change from the minute to the hour. So if it's going to be raining today or sunny tomorrow, it's what we get. It's a short-term experience, and it's things like nor'easters or hurricanes or heat waves that are with us for a little bit of time, and that's kind of what we're experiencing day to day. So we can't, with this project, we're talking mostly about adaptation. And we can't talk about adaptation without talking about mitigation. As most of you will know, the greenhouse gases that are emitted are what is creating a lot of the heat that we're seeing. And the warming of the planet is generally making the usual weather systems change, and the patterns that we're used to seeing change. So it's changing the climate as a whole. And we know that the changes that we're expecting are based on a certain amount of greenhouse gas emissions and carbon emissions, and there's usually a range to those. There's the worst case scenario, which is like higher emissions if we don't do anything about it, and there's lower emission scenarios where the effects of climate change won't be as much. And so we need to keep that in mind when we're talking about a lot of this stuff, that when we're trying to adapt to it, we need to figure out what we're trying to adapt to, because the more emissions that we let out, the more that we're going to have, the more climate change we're going to see, and the severity is going to increase. And so some brief expected changes that we're looking at seeing based on the climate change scenarios and the science. We're going to be seeing higher temperatures. We're going to see sea level rise. changes in precipitation, and that's like the amount and the timing of the precipitation, and more frequent large storms. And a lot of these are things that we're already experiencing based on what we would have in past climate. And so what can we expect in 50 years? This is kind of an arbitrary date. There's a lot of scenarios that go up to 2100, but I thought 50 years out would be a good place to look at. So we're expecting the average temperature to increase 6.4 degrees Fahrenheit. Sea level rise will increase 1.3 to 4.2 feet, and it could be even more depending on how we see the sea ice melting. High tide floods, which are floods of 1.75 to 2 feet above the daily average, what used to be the daily average high tide, could be up to 250 days a year. So that's 250 days of coastal flooding, which is crazy to think about. And today's 10% or 10-year rainstorm is expected to increase from 2.5 inches to 3.5 to 4.5 inches. So that those storms that we expect to see once every 10 years are going to be quite a bit larger. And then what we call a 1% flood event will cover 75% more area in 2070 than it does currently. And on the right, you can see the image, and this is kind of how the Massachusetts temperatures are going to change over time. Right now, we're of course where we're supposed to be, but as we go down, we see 2050, the heat will be like Maryland. In 2070, it'll feel like North Carolina, and then kind of closer to the end of the century, the hot days are going to feel like Georgia. And so first we'll talk about heat and some of the effects that we're expecting to see heat, and some of the effects that we're likely going to see is with increased temperatures becomes a decrease in air quality. And developed areas like more urban areas or town centers that have more pavement and more buildings are going to be more affected by heat waves. And then heat plus the increased heat plus the increased chance of drought means there's a greater chance for fires. And as I mentioned before, the temperatures are going to increase 6.4, are expected to increase 6.4 degrees by 2070. And what that ends up meaning is 58 less freezing days than we're seeing now, which has a big effect on vector carrying animals and insects like ticks and mosquitoes. And then we're also expected to see 20 to 49 more days above 90 degrees, which will really stress a lot of people. And usually this proportionately affects lower income or people that are already vulnerable. And so these are some of the human effects. So there's going to be more asthma. People that work outside are going to experience a lot more heat, and then the vulnerable populations are going to feel that even more. And as on the bottom left, you see the mosquito, and those we're likely to see more of that in the future. And something that a lot of this is kind of human centered, and a lot of this project is kind of geared towards looking at the impact on human beings, but there's also going to be a huge ecological impact to the species that live here, and how they cope with the climate change. The next big topic is sea level rise. On the right you can see a picture that's a high tide. It might be a higher than normal high tide, so not like your average high tide, but it's still there is a walkway there. People aren't expected to sit in the water on that bench. But we're going to see, because of sea level rise, we're going to see an increase in tidal flooding. It's going to affect commutes and recreation. Some of the high tides can affect routes that people take to work or just to recreate. There's going to be increased storm surge. So if a storm hits when there's a high tide, which is higher than normal, then that's going to mean even more flooding. And what we've seen is that there's sea level rise, but the high tides are increasing more than we're seeing the sea level rise. And when we have large rain events, it can make river flooding worse because there's no place for that water to go. And this can be, as I mentioned before, it could be up to 4.2 feet by 2070, and the sea level could rise up to 8 feet by the end of the century. Here's some pictures. This is a high tide, and you can see these cars are already in the water. And then the next is Milton Landing, and as you can see, we're already seeing the huge effects. Like these were created in places that would not have experienced flooding when they were originally there, but now they are seeing a lot of flooding. And now this is kind of the main focus of the project, which is precipitation change and the flooding that we're going to see from it. We'll see a few pictures, a few maps coming up that'll explain a little bit of this pictorially, but there's going to be a change in the timing of the rain. So we're used to seeing a certain amount of rain in certain seasons, and although the rain amount isn't going to change that much, when we're seeing the rain is going to change. And that's not only the seasonally how we change it, but our periods between rainstorms are also going to increase. There's going to be increased amount of rain from large downpours, and there's going to be more possibility of seasonal drought as the timing of the rain changes. And so this is some predictions for Massachusetts. I've highlighted the Neponset River watershed. You can see annually there's not that much of a change. There's like a little bit of increase and a little bit of decrease. But then as you look at the summer on the bottom left, basically right where the Neponset River watershed is, there's going to be a decrease and more likelihood of drought during the summer, as opposed to a lot of the areas around us. I'm not sure why that happens, but that's what the models are looking at. And then in the winter, we're looking to see an increase in rain and precipitation. So we'll see more rain and precipitation during the winter. It probably won't be snow because of the heat going up, but we'll see more of it during the winter. And then this is what we've seen already. So for this, a very heavy precipitation event is a 1% storm, so something we'd expect to see once every 100 years, which of course being more often than that. And in the Northeast, the change we've already seen, we're seeing a 71% increase in the very heavy precipitation that we're seeing. And that's in relation to a lot of the country, is drastically more in the New England area. And here, as we start talking about rain and talking about flooding, there's some things that affect that a lot, and a lot of it's down to how much pavement there is, or how much impervious, so like where the rain isn't able to get into the ground that there is. On the top, we see a normal natural ground cover for a forest, and in cases like this, only 10% of the rain that falls ends up running off and not either sinking into the ground or going up into the air. But on the bottom, in the more urbanized and more developed areas, that runoff is 5 times higher and is up to 55%. And that water ends up going into the river, into people's backyards, into the storm drains. And it's kind of a normal thing that we see this much cover. So on the left, you can see a parking lot. And this isn't a really urban area. It's kind of like a center of a more suburban. It's just a developed area. And so large parking lots, lots of buildings equals a lot of runoff. And so in our modern day environments like this, you can see the river that runs basically down the center. There's a lot of development. There's houses, driveways, roads, and on the bottom right, there's large parking lots and kind of industrial uses. And all these add up when we talk about 5 times more runoff, and that all ends up in the river that's in the center of this. And there's 2 things to kind of point out here. One is that all this development right next to the river, it does 2 things. It either displaces water that would end up going into the floodplain, which means there's more water in the river and there will be more flooding elsewhere. But it also means that these areas are more prone to flooding. And as we can see increased flooding, these areas are going to be even more prone to flooding and to having damages from that. And what happens to all that water that's falling on the surface is it gets on top of your house, goes down your gutters, ends up in your driveways, the roads, and it ends up going into a storm drain, or sometimes directly into the river. but it goes from that storm drain directly into the river, and it picks up all the pollutants that we would see on the surface. And there's, in most cases, there's no filtration. We'll talk a little bit about nature-based solutions and how those can help not only to contain some of that water, to slow it down and in some cases sink it, but it also acts to catch some of the pollutants before they end up going into the river. And so these are some examples of flooding. This is some stormwater flooding where it's just not getting down the drains fast enough and cars are going to have to go through it. And then in the next one, this is the Norwood Hospital, which many of you have heard about. And this is an example of stormwater, the stormwater runoff and of the system that carries it to the river, to a water body, not working. This is with that system working as it should, but there was too much rain fell, and the system just couldn't deal with that amount of rain. And that's something that we're expected to see more of. And as the amount of rain we get in the storm increases, events like this will likely become more frequent. But we've done this before, and I put the asterisks there because this is different from what we've kind of dealt with before. There's been other global environmental problems that over time we've changed and we've dealt with, and has allowed the environment and nature to kind of heal itself. In 1962, Silent Springs came out, which is about pollution in water and air. Because of that, there was a lot of chemicals that eventually got banned, like DDT. And as we've seen from bald eagle populations, I know it's something that I've seen in my lifetime, is that there's a lot more bald eagles around, and that's has to do a lot with this book and the getting rid of the DDT. The first Earth Day was in 1970, so there's like the social movement, but in the same year the EPA was created and the Clean Air Act was passed. And there's like the social energy that's like moving in a certain direction, and that was kind of mirrored in what the government was doing at the time. In Massachusetts in 1972, so not much later, the Wetland Protection Act was put into place that created a lot more protections for the wetlands and has kept a lot of them over time. In 1985, the hole in the ozone was first discovered, first published. And 2 years later, the Montreal Protocol, which was this multi-country agreement to phase out ozone damaging chemicals, was created. And since then, there's been a huge recovery by the ozone layer. And most recently, I read that within a decade, it's going to be completely healed from what it was before. So this large global event, this global environmental problem was dealt with quickly and has made a great change. And then in 1996, the Massachusetts River Protection Act was passed, again, adding additional protections to our waterways. And then there's kind of a generational change that's going on now too, where there's a lot of younger people and a lot of other people that are really inspired. And as people change, as those people start getting into government or getting into different organizations, there's going to be a kind of a generational change with how we look at climate change and what we're doing about it. So we've done this before in certain cases, so there is some hope that we can do this again.
Great. Thank you, Jeff. Hi, everyone. Thanks for joining again. My name is Vandu. I'm Senior Environmental Planner with MAPC. And to Jeff's point, we've done it before, and I would say that we're doing it to combat the changing climate as well. And in the next few slides, I'll walk through what should we do to prepare based on sort of the information that Jeff just provided and why it's important to work together. So as part of this project, we are also working with the communities in the watershed to build a coalition, naming it the Neponset River Watershed Climate Collaborative. With the collaborative, we'll facilitate coordination on a watershed scale to develop and implement climate adaptation strategies, thinking back of what are the climate solutions, the solution strategies that we can engage and implement to prepare for and adapt to the changing climate that Jeff presented earlier. For example, the extreme storm events, extreme temperatures, drought, flooding, especially flooding. I think that's kind of on the mind and critical for everyone as the result of the increased frequency and volume of rainfall. And I want to acknowledge that, what this collaborative will help streamline efforts and partnerships, leveraging opportunities to share best practices, experience, and resources. But we're able to build this collaborative because of all the great work that has been happening in local communities within each of your communities. You've gone through the MVP planning process, identifying vulnerability and things like that. And so basing on all of that, that's how we can help strategically pull together the implementation roadmap for the collaborative, the communities within this watershed region. Next slide, please. And so again, why is it important that we work together? And again, kind of together we'll make it better, right? Given that we can find synergies to collaborate on projects, pulling funding together to have bigger funding sources and better impact and at watershed scale, at regional scale, really optimizing the benefit both to our built environment as well as to our social environment, as well to the people, the priority populations that identify within each of your community. And of course, most importantly, we avoid reinventing the wheels based on the best practices, the experience and work that have been done in each community. And of course, making progress on similar works that we can learn from each other. Next slide, please. So how are we going to do this? And so again, the project team look at all of the different priority actions that have been identified by the community participating in this collaborative, and kind of pull out, see where are the common threads, what have been done, as well as where you're seeing as the critical sort of key strategies, critical strategies to an urgency of it, based on, again, the different climate hazards that are priority to the communities. Again, there are extreme storm events, extreme temperatures, drought, and flooding. And so we're using, at this point, a very high level evaluation criteria to help kind of distill and refine a little bit more down to what would be the top priority strategies for adaptation solutions for the climate, for the collaborative. Again, this watershed kind of scale, higher level, keeping in mind that progress and efforts are still ongoing at local communities as well. So with that, we're looking at whether a strategy has any contribution to improving social equity for the communities in the watershed. What are the potential co-benefits, such as increased public access, economic, workforce development, public health improvements, safety, or improve the natural habitats, biodiversity that you all have been working very hard to protect and preserve. And then the two most important things is the level of efforts for implementing these top priority strategies. What would it take for the municipal staff in each of these local communities to be involved? What is the capacity should look like to implement or to participate in the implementation effort? And then, of course, cost. That's the main questions everyone always asks, like how is it financially feasible? And so these are sort of the very high level estimate assessment that we do to kind of help score, quote unquote, score the strategies that we identify as the common theme we're seeing. And these would rise to the top that we see as sort of the immediate next step for the collaborative to take on and implement in the upcoming years. Next slide, please. In the next 4 slides, I just want to share with you some of the example top priority strategies that came out of that evaluation exercise. None of it should be new or surprising to you based on what Jeff just shared in terms of the data that were the climate change impacts that we're expecting anyway. But, one, conducting a regional flood study that's currently in progress, and the team will talk about a bit more about that later today as well. And then, evaluating and upgrading infrastructure, continue to restore, protect natural resources like wetlands or open space, thinking about the systems change that we could tackle, thinking about zoning, regulation, bylaws, that can allow for better and smarter growth. And of course, continue to kind of incorporate the climate change projections in the way we design and construct our systems, especially our stormwater management systems. And of course, thinking about more nature-based solution, living with nature, learning from nature to build things that, will, of course, be able to adapt and prepare for this changing climate. So that these are some of the top strategies that to address flood risk. And then next are some example strategies related to extreme storms event. And so just a couple of them, again, I think thinking about finding synergies and regional coordination for emergency response plan. Of course, things just don't stay within a municipal boundaries. And so being able to share services, being able to kind of have quick response to support the communities across the region is key. And of course, with that, being able to protect roads, bridges, things that, cross boundary, and of course with community systems as well, communication systems as well. And then next is some examples on extreme heat. Again, this is super important, and as we're heading into the summer, I think last year we've seen kind of record extreme temperature, even in the summer as well, and more frequent heat waves. And so with that, and kind of thinking about programming, messaging, and educational outreach to help the public understand the risk of the extreme heat, as well as the public health around it, as well as resources available from cooling centers, as well as what to look for in their buildings, in their homes, to kind of really protect and make sure to prevent the extreme heat-related illnesses, especially for vulnerable folks that have pre-existing conditions. And then as part of it is increasing parks, open space, green space, pocket parks in neighborhoods that are currently lacking to really provide additional resources for the communities and in a convenient way as well. And I think like every kid, I also love spray parks and such as to have places to cool down are some of the, so these are some of the example strategies that we didn't create, but came from your plans and through our evaluation sort of rose to the top as the priorities that we can address as a regional collaborative. And then the last one is are some of the example strategies on how to address drought and wildfire, thinking about the native plants, species, things that are more resilient to windstorm, drought, or pest resistant, water conservation programming. How can we coordinate that to make sure that we not only kind of support the water quality, but also conserve the water for the long run as well. Brush fires, mitigation plans. So some of these actually should be part of your hazard mitigation planning as well, but it's always good to sort of, again, have this regional collaborations and coordinations for better use of resources and funding. So yeah, so that's what I have to share. And we, as part of this, also the collaborative has started develop a framework which is an implementation roadmap that really laid out all of this. So in the upcoming weeks, when we're wrapping up, hopefully we'll be able to share with you, and you'll be able to look more in details and continue into the implementation phase. So with that, we're open for questions, anything that you would like to comment on or ask us about at this point. I'll turn it back to Carrie.
Thank you so much, Van. Okay, so next we are going to break out into 2 breakout rooms. And we'd love to get some feedback from participants tonight on a couple of things. And in each breakout session, you'll have a facilitator who have some questions for you. We really are interested in sort of what it is that is the highest concern for you when you think about climate change and resilience needs in your community. Whether you have any reaction to some of the examples that Van just described. And we're also looking to the future and trying to make sure that we're really engaging with as many people as possible. And so we'd love your ideas about either community groups or different methods of communication to reach people. So that would be great. And these are just some group guidelines. They're just general good manners when we're in our groups. So we appreciate it. Ian, do you want to send people to groups?
Nobody wanted to leave those breakout rooms. You all had to be kicked out.
We did not. And as a result, I really want to encourage people to email us with additional feedback that we didn't get to talk about. Again, you know, what is it that your top concerns are, and you know, what do you think your community should be looking at, and what about those engagement strategies? Who should we be reaching out to, and how? So thank you so much. I saw that we had some great notes. I know it was short, but we want to be respectful of your time and make sure that we explain what this project was. So I'm now going to turn it over to Indrani from Weston and Sampson.
Yes, thanks a lot, Carrie. And I will go ahead and share my screen as I do that, my colleague Jenny Moonen and I will introduce ourselves as well. So bear with me for a moment, please.
So hi, everybody. I'm Jenny Moonen from Weston and Sampson. I'm a senior project manager and have been working in conjunction with the team here on developing a watershed-wide flood model. And Indrani.
Yeah, can you all see my screen?
Yep.
Great, thank you, Jenny. I am Indrani Ghosh. I am a resiliency senior technical leader at Weston and Sampson, and it has been great working with the team here on this first ever flood model for this Neponset River watershed, and we are very excited to speak about some of the findings from this phase of work with you all today. With that, I will dive right in. A lot of these concepts have been explained by Carrie also in the beginning and some by Jeff, but I will be very brief with some important additional remarks on this. So just expanding on what Carrie said at the beginning, what is a watershed? It is an area of land that drains to the same water body, which in this case is the Neponset River and hence the Neponset River watershed. It is important to note that some of the towns in this watershed have developed their own individual stormwater flood models that looks at the effects of their drainage infrastructure risks, but we really did not have a regional model until this time. And as we know, rain does not follow municipal boundaries. And so runoff and flooding does not follow those jurisdictional boundaries as well. So this was really an attempt by the team to look at those cross municipal boundaries and to evaluate both flood impacts and flooding solutions and their benefits thereof at a regional scale. So for example, what happens in Stoughton may affect Canton, or the types of solutions that get implemented in Dedham may benefit or impact Boston. And without the tool of a regional flood model, there really isn't a way for us to quantify or show those impacts. So what is a hydrologic and hydraulic model? It is essentially a mathematical simulation of rainfall falling on the ground, generating runoff, and causing flooding. So this model is intended to represent where precipitation goes, how long it stays in that built and natural environment, and it can be used to predict a variety of rain events. And ultimately, the model shows a representation of where the flooding is occurring now, where it is expected to occur in the future due to climate change. And we can also model flood reduction strategies, as I mentioned, to see what works and how much we would be able to eliminate flooding. So as a result of this, you see this beautiful picture of how this model was developed. The project team worked very hard to gather information from all the towns, from you all. So thank you to all our municipal partners for providing this information, the information about their drainage infrastructure, past experiences with flooding, and also your feedback through this meeting and additional survey feedback that you all have provided will be included to make this the best model possible. So what we want to highlight here are some of the salient features that we included in the model. This watershed, the model for this watershed covers over 107 square miles of area. We are modeling close to 157,000 linear feet of the main stem of the river. However, the flooding is not contained only within the main stem. So we are looking definitely at the tributaries of the Neponset, which constitutes of approximately 600,000 linear feet. And we are not just looking at the water bodies, the open surface water bodies, we're also looking at the pipes, the drainage infrastructure that we don't see above ground, that's underground, but that contributes significantly to the flooding issue. So that's the pluvial flooding issue that we're talking about. But to better model and simulate the flood risks, we have to consider the several dams that are in our watershed. We're simulating the 50 dams here as part of this phase of the work. And we're also considering over 380 culverts as part of this model. And this model that we have developed is a combination of one-dimensional model, which includes all of these features that I just mentioned, but it also has the 2D impact, which essentially shows you it's a representation of the extents and depths of flooding. So the flood maps that you will see throughout this presentation are an artifact of this 2D flood model, which essentially shows where the flood waters go, how far they extend, and how deep they are. So Jeff spoke a little bit about this in his introductory remarks, and we wanted to bring this information back to you because this is really the essence of this project, is to understand the future flood risks. So the model that we developed gives us the ability to simulate future storms. This slide shows the best available rainfall projections that the state of Massachusetts has adopted. And these projections are very specific to the Neponset River watershed. They are based on the climate resilience design standards tool that the state has developed, and it has been championed by the Resilient Massachusetts Action Team. So what you're seeing here on this slide show from left to right, the present day storms that we have today, what the depths of those storms are likely to be by 2030, 2050, and 2070 from left to right. And what you're seeing here, if you follow the dotted orange lines, is that there is likely to be an intensification of frequency and intensity of these storms from today to what we see in the future. For example, the 25-year storm of today, which has a 4% chance of occurring in any given year, is likely to be the 10-year storm by 2050, or a 10% chance of occurring by 2050. The 500-year storm of today, which is the 0.2% chance of occurring in any given year, is likely to be the 100-year storm, or the 1% chance of occurrence by 2070. So we ran the model to understand what the flood risks are across the watershed today and how these risks are likely to be exacerbated in the future. So what you're seeing here is a graphical representation of the acres of flooding that we are likely to see from these different present and future storm events, and how much additional runoff volume we are likely to experience as a result of those future flooding events. So what we are seeing here, though, is with the 10-year storm, we're likely to experience a 22% increase in additional flooded area, and almost a doubling of the 100-year doubling in terms of volume for that storm event. I would also like to mention that the model has been calibrated and validated for actual storm events, such as the storm that we experienced in spring of 2010. Many of you all may remember it was a continuous rain for over 2 weeks. And that was about 9 inches of rain at the peak of it in 48 hours, which corresponds to a 50-year storm. And then our more recent memory is Ida, which is about 4 inches of rain over 17 hours. That roughly corresponds to a 5-year storm of today. And you can see the area of flood volumes from those storms as well as simulated in the model. So that was the summary in the form of a table, but a picture is worth 1,000 words. And now that we do have a model to look at, we have the ability to see the spatial distribution of that flood risk across the watershed. So the map on the left shows the increase in flooded area for a 10-year storm in the future, that is 2070, compared to today. And the darker colors correspond to the larger increase in flood area in terms of percentages. So for example, the Purgatory planting field brook subbasin in Westwood shows an increase of between 50 to 60% higher in the future compared to what we see today for a 10-year storm. And we are also summarizing the results at the subbasin scale in terms of runoff volume. And you can see a relatively uniform sort of increase in flood volume with very high numbers corresponding to greater than 80% in these parts of the watershed. And we have the ability to zoom in and look at these impacts at a finer scale. So for example, what we're seeing here is the Dedham Manor neighborhood. And we'll be speaking a little bit more about it in terms of solutions that we've explored. But what you are seeing here highlighted in the red circles are where the flooding is today on the left panel from a 10-year storm, and where the flooding would be if we do nothing from a 10-year storm of the future. And so this shows the colors in blue correspond to the different depths of flooding, the lighter blue with shallower depths, the darker blue with deeper depths. And this essentially shows an exacerbation of flooding in the future to the built infrastructure areas, as well as emerging new flood pathways in the future with, as shown in this figure here highlighted. We could zoom in to any other location. Like I said, this is at the watershed scale. So we're now at the Norwood Memorial Airport, as you can see here. And what we similarly, we see an exacerbation of flood extents and flood depths. And I'd like to mention that this was the first phase of where we started developing the model. The subsequent phases, which we will be talking a little bit at the end of the meeting, will dive further deeper into the impacts on critical infrastructure within the watershed, such as looking at impacts on schools, on hospitals, on emergency shelters, and so on. So that was a lot about the risk. We now transition over to the different types of flood mitigation scenarios at the watershed scale that we looked at. So we looked at 3 types of solutions and scenarios. I'll briefly touch on the scenarios and then Jenny will cover the results through the flood model. So we looked at the first scenario that we considered was really a very robust implementation of green infrastructure solutions in areas that are already developed. So we looked at increasing storage in of about 4.5 inches of runoff across 50% of the impervious area in the watershed. And then we also looked at larger parcels that have the ability to mitigate more stormwater by storing an additional 4.2 inches of runoff. And we think of these opportunities where we can implement bioswales or bioretention basins in parts of the watershed that are already developed. The second type of scenario that we looked at was combining the green infrastructure in already developed areas, as I just mentioned, but supplementing that with expanding natural systems and increasing storage in those natural systems by enhancing the storage capacity. So we looked at the opportunities of increasing our existing wetlands by 20% by increasing flood storage there. And we also looked at upland flood storage opportunities in different parts of the watershed where we could have additional flood storage to let the peak of the storm pass and then gradually release the storm. So additional flood storage in upland ponds in the watershed. So that was scenario 2 combined. And then the final scenario that we will be discussing today is looking at, again, the same green infrastructure solutions implemented in already developed areas. And then we looked at what additional opportunities could we get if we were to develop the undeveloped, unprotected lands in the watershed, and we were to use stringent stormwater requirements in those areas, such as retaining an additional 1.3 inches of runoff of rainfall. What would that look like? And so those were the 3 types of solutions that we looked at. And with that, I will transition to Jenny to speak about the local solutions that we also evaluated.
So Indrani, under solution 2, mentioned that we looked at ways to store water in upland ponds, think about stream restoration, expansion of wetlands. We worked with all of our member communities to understand favorable locations for very large scale projects or site-specific projects. When I say large scale, I'm talking about a football size field flood mitigation solution. And this includes perhaps removing a dam, creating storage by building a storage basin, modifying a dam in how it operates, or actively managing that dam to raise or lower water before or after a storm. This also includes what's called reactivating floodplain. So that might be creating space that used to flood but doesn't flood currently because of our man-made environment, or building waterway diversions that are constructed to move water from where there's a flood prone area to where there is a more resilient area that's less subject to flooding, as well as creating floodable spaces like parks that can temporarily flood, but drain following a storm. We ran the 3 scenarios that Indrani discussed, as well as those individual sites, through the model and looked at what benefit we can see from those results. So this graph, these graphs that you're looking at show the results of the 3 scenarios. And the bar that's in gray is how much flooding in area you would expect to see under present day conditions with no action taken under the 20-year 2070, 10-year 24-hour storm. The blue bar shows, the gray bar is the present day, I apologize. The blue bar shows the 2070 anticipated flooding, and the orange bar is showing what reduction you might see compared to that projected future flooding by undertaking these scenarios. And we found, for example, scenario 2, so that is the example where we are talking about implementing widespread widespread green infrastructure combined with expanding natural systems like wetlands and restoring streams and upland ponds. And you can see that that scenario results in a 14% decrease from the projected flooding that might be experienced in the year 2070. So we're reducing that expected flooding, but it is still a 7% increase from our present day flooding. And if we look at it in terms of volume itself, we can see a separate way of thinking about it. So there's area and there's amount of water, that volume of water. And we found as well, the results for scenario 2 yielded the most significant improvement. So if you look, for example, at the middle bar here, the gray is our present day flooding with no action taken. The blue is the 2070 anticipated flooding under a 10-year, 24-hour storm. And the orange is a 41% decrease from that projected flooding. That's pretty significant. But it does result in a slight increase from our present day flooding, but it's still a good reduction of our projected conditions. This image shows some of the model viewer results. Indrani has explained how these work, right? The darker blue is deeper and the lighter blue is less deep. But what you're really seeing here is that the benefits of the mitigation scenarios can be understood in terms of watershed-wide decreases in that flooded area and that runoff volume. And those benefits do vary across the watershed and have a very real impact at the local scale. So for instance, right here on Route 1 in Westwood, compared on the left, no action, and the right on scenario 3, you can see how there's an elimination of flooding on the portion of the Boston Providence Turnpike. And going back to the subbasin scenarios that, or excuse me, zooming in, kind of thinking on the subbasin basis that Indrani had been speaking out before, we can once again see how there are different impacts to different subbasins from the scenarios. So for example, scenario 2, which we found to be the greatest potential improvement to the watershed for future, to mitigate future flooding, is showing that greatest percent decrease. And when we think about it again in volume, we're seeing those similar reductions under scenario 2, but it is geographically dependent on that subbasin and the area and the individual site conditions. Dedham utilized the model during this project to focus in on a particular neighborhood that has approximately 2,000 residents, 460 parcels, and it's 98% residential. It's called the Manor neighborhood. It also has what's known as environmental justice communities, which are communities that may be language or, I'm gonna say this wrong, but financially isolated. There are many frequent flooding complaints, and there is documented flooding in the street and in basements now under current conditions, and very many concerns by the residents and the town about future impacts to this area. Dedham was able to utilize this model that was developed and look very strategically at this particular neighborhood and come up with a significant number of solutions for some of the larger parcels, as well as some even just things alongside the road, like Indrani mentioned, bioretention and bioswales, and evaluate the benefits that they would achieve through the model. So to wrap up, and Indrani, jump in with me here if I'm, I think together we can share this. What is the punchline, right? What are we thinking here at the end? Based on acres of flooding, the watershed is projected to have more flooding by 9 to 24% by the year 2070. Now, I know I'll be quite old by the year 2070, but I'm certainly concerned about this. We are seeing that there are aggressive measures that can be taken as a region in a collective effort that reduce the impacts due to flooding. And we talked about some of those on the previous slides, and you saw the decreases with the bar graphs. The solutions considered in our work were able to reduce the projected future flooding by about 18 to 64%, which is pretty significant. And that means starting now. The effectiveness of these solutions does vary significantly throughout the watershed. Communities like Dedham can use this flood model to explore their specific neighborhood concerns and evaluate solutions. And communities can work together and use this flood model to assess their risks and impacts at the regional scale, as Indrani mentioned at the beginning. Did I miss anything, Indrani?
Sorry, just coming off the mute button. No, that was great. Thanks a lot, Jenny. I will just add 2 additional things here. As Jenny mentioned, we were considering through this process of showing you the results, we are looking at the 2070 10-year storm, which, that's seven inches of rain over 24 hours, which is not trifling. It's certainly a large volume of rain. So all of these improvements were seen for that large storm, which gives us the hope that there is likely to be greater benefits for present day storms, as well as the smaller and the more frequent storms that we see today. And this evaluation of the flood risk at the regional scale is really the evaluation of risk and impacts at the regional scale is really the differentiator and the unique contributor of this project. And with that, we are on our last slide, and we're happy to report that all of these results and scenarios that we discussed at the meeting today are available on a public facing viewer. We will put the link to the viewer in the chat in a second. We will be doing in the coming days, NEPRA and the project team will be working to develop a tutorial video to show you all how to use the viewer. It's going to be a dynamic interactive viewer, which you can look through and see all the results that Jenny and I discussed. And you can look at it to understand both the present day as well as future risks of flooding, as well as see what the solutions that we discussed may do to mitigate flooding at the local scale as well as at the regional scale. And with that, I will hand it off to Carrie.
Great, thank you both so much. So right now we will open it up to sort of immediate reactions. Do you have any questions about the flood model itself? And you can raise your hand using the raise hand icon down the bottom of your screen, or you can put your question in the chat. No questions right away. Well, it's a lot of information thrown at you all at once, and we will be hosting the flood viewer on the NEPRA website. We have a project website already, and that will be updated once this project is done. We'll have all the meetings up there. We'll have all of the final report up there, as well as the viewer. So one last go for questions. All right. I'm also going to show you my email address at the end of this. And I'll stick it in the chat here. If you have questions in the coming days, please do not hesitate to reach out. And then I'm just going to share my screen real quick. Sorry, I thought I was starting. Here we go. So just wanted to let you know that this is really just the beginning. We have partnered with 10 of the towns that participated in this first phase to apply for a second MVP grant. The way this application was structured was to work over 2 years instead of trying to get it all done in 1 year. And again, it's pretty ambitious in scope. We're hoping to refine the regional flood model, get some more information about some of that infrastructure, such as dams that some of you expressed concern about. We'd like to drill down into some priority areas that are high risk for flooding or have really important infrastructure assets, town buildings. We want to advance the Neponset Region Climate Collaborative. We're planning to do a roadshow and come to all of your communities and talk about the framework and see if we can put together a steering committee to really formalize the group and get started implementing some regional projects. We'd like to organize a community advisory group, and that's part of the reason we'd love your ideas about community engagement. You know, what groups should we be reaching out to? Are there community leaders, individuals that we should be reaching out to? Because we would very much like to make sure that your concerns are elevated and the collaborative is working. We'd like to engage residents all over the watershed around climate change and adaptation opportunities generally. I think a lot of people hear about the dire consequences of climate change, but really it's important to know that there are things that we can do to mitigate those effects. And finally, we'd like to do another technical assistance workshop with municipal staff and really drill down into some policy solutions to make sure that, for example, construction is done in a resilient manner moving forward. So more to come. We'll find out in August or September if we've received that grant. And again, Dedham stepped up and agreed to be the applicant. So thank you again to the town of Dedham. So I just want to thank you again for coming tonight and spending this time with us. And again, I'm going to send out an email to all of you after in the coming days. And please reach out with any questions as you're looking at the viewer. You know, let us know what you think. And we're looking for continuous feedback. So please don't hesitate to reach out. And with that, I think I can let you go. Have a great night.
Thanks, everyone.
Thank you.
Thank you.
Thank you for hosting us.
Thank you.